What's up folks, welcome to Slake Academy. I'm Pradeep. Today we are going to see exercise 3 of polynomials of class 10. Exercise 1 and 2 we have already solved. That I'll just give you in the description, you can go through. Okay, so before going for exercise problems, we'll just discuss few important points that will definitely help us in solving exercise more easily. So here these things actually we have discussed, so we are just revising this. So here the polynomial can be said anything which is having the power as 1. If that is power as 1, definitely we can say that is a linear polynomial. For suppose if that is having power as 2, so definitely that is a quadratic polynomial. If the equation is with power 3, definitely that is a cubic polynomial which is having the power as 3 in the expression or in the equation. So now here either power 1, power 2, power 3, even if the power is more than 3 also, all these particular equations or expressions can be said as polynomial expression or polynomial equation. So now few things which we have to understand here. Here is the second point they are giving. Whatever the coefficient, either a in this particular equation or b or c, this coefficient, whatever the values which we are taking, that should be a positive value and that should be a real number. It need not to be a positive. The particular thing is that it should be a real number, not an imaginary number. Okay, if that is imaginary, definitely we can say that particular number will not be a polynomial. Okay, so that is one of the rule where the a value, that is the coefficient, should not become 0, because the coefficient, that is a here, the x square, if that a is becoming 0, this full a x square will become 0. So if that a x square is becoming 0, we can't say it as quadratic, because the power 2 will go off, so because that will get cancelled. So for the reason that should not become 0. So this is the second point which we are observing. And the third point, if you just see, we were just checking out the zeros of the polynomial to x-axis, right? From beginning we were just seeing, we're just checking out like this in the graph. When some graph is made, suppose some graph has made like this. So if this is the x-axis, right, then this is the y-axis. The x-axis, the graph is touching x-axis over here and over here. So because the graph is touching x-axis at two different points, see here, here is one point and here is a second point. Because that is touching at two different points, we were saying the zeros of polynomial as 2. It is all about how many times the graph is touching x-axis. So because we are doing with respect to intersection of the graph in x-axis, we were saying that is y equal to p of x, that is p of x, which is intersecting x-axis, that is a point. And the next point, if you just observe here, if that is a quadratic equation, the zeros we will get, about 2 zeros will be getting. Okay, it is not compulsory that it should get only 2 zeros, but maximum times for the quadratic equation will be getting only 2 zeros for the polynomial. If that is a cubic polynomial, definitely that particular cubic polynomial maximum means most of the cases the polynomial will be getting 3 zeros for the particular polynomial. If that is a real, if that is a linear equation or a linear expression, most of the chances of getting a linear equation will have only 1 as the zeros of the polynomial. But it is not compulsory that linear should get only 1 and quadratic should get 2 and cubic should get 3. It can vary at certain cases. Most probably they will be getting as per what we discussed now. So let's see the next thing here. Here is the point: if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, where a not equal to 0, then here is the point: alpha plus beta is equal to minus b by a and alpha beta equal to c by a. So these particular 2 points, means this particular fifth point we'll discuss more clearly by taking certain example, so that we'll understand more clearly. So let's discuss. I'm just taking certain example and we'll discuss that. For suppose I'll just take example x square minus 2x minus 8. Okay, so if this we just observe here, this expression is exactly looking like the quadratic equation, general equation now. So I can write here ax square plus bx plus c. Okay, so now this is exactly looking like quadratic equation. So what is the quotient of x square? That is 1. So we can write a equal to 1. Here what is the quotient? B equal to minus 2. What is the value here? That is c equal to minus 8. We got ABC values here. So here are the two things which we'll observe here, that is sum of zeros and product of zeros. So now I'll write here sum of zeros. sum of zeros in the sense, one thing which should be much more clear here, sum of zeros, for that we'll be writing minus of this coefficient, whatever the value, the coefficient of x, coefficient of x, that is nothing but b here, okay, and by, we were saying a, see here, a in the sense coefficient of x square, okay. This is the way we'll write the sum of zeros of the polynomial. So now sum in the sense whatever the values which we are getting for the polynomial, other way we can say the roots which we are getting, when we add them, whatever the value we are getting, that should be equal to this particular form minus b by a. Let's check it out for more clarity. Suppose here this is the equation, I'm just taking the same equation, x square minus 2x minus 8 is the equation. If we say that is equal to 0, so that we will just get the roots for that and we can easily make it out. I'll make little more space. So that is, here is the coefficient 1 and here is the constant 8. So 8 ones are 8, 1 into 8 is 8. So 8 in the sense we can take 4 2s are 8, which it is even satisfying the middle term also. So I can write here x square, this is, I'm just writing it as plus 2x and minus 4x minus 8 equal to 0. So minus 4x plus 2x, again that will be giving minus 2x, okay. So here I'll just take x common, so I'll be getting x plus 2, and here I'll take minus 4 common, so I'll be remain with x plus 2 equal to 0. So if I take x plus 2 common overall, and I'll be remain with x minus 4 equal to 0. So here x equal to minus 2 we are getting, x equal to 4 we are getting. So these are the roots, x equal to minus 2, x equal to 4 we are getting. In other ways, to better understand this x equal to minus 2, instead of writing x equal to minus 2, we'll write this as, just as we wrote here, see, we have written this is alpha plus beta, right? So we'll write alpha equal to minus 2. Instead of writing this x equal to 4, we'll write the second value as beta equal to 4. We're just taking like this. So now whatever the things we have taken sum of the zeros, that is alpha plus beta. So we'll write here alpha plus beta equal to minus quotient of x. Quotient of x in the sense here, quotient of x is nothing but it is b, but in the formula it is minus is there, so minus b by quotient of x square. Quotient of x square in the sense that is simply a, okay. This is the form which we have to remember. So now whatever the values which we got, that we'll submit here. What is alpha? Alpha is minus 2. What is beta? Beta is 4, right? Beta is 4. And what is minus b? Here b is minus 2, so I can write minus of minus 2. What is the value of a? A we got as 1, so we'll write over here. So now if we just solve, minus 2 plus 4 is how much? That is nothing but 2 we are getting, okay. So this is equal to minus of minus is how much? That is plus 2. See here, these both are equal which we are getting. So that both values should be equal, then only whatever the zeros of the polynomial we have taken, that will be a perfect value. So this we have shown for only sum of the zeros, the same thing which we have apply even for the product of zeros also. So anyhow, I just want to make you clear that whatever the given equation or expression, that should match the sum of the zeros, that is alpha plus beta equal to minus b by a, and for this is for sum of the zeros, okay. For product of zeros, that is alpha beta equal to c by a, this also should match. For the sum of zeros, that is alpha into beta should be equal to c by a, that should match, okay. So however, that clarifications we will be getting once we start the exercise problems. I am just trying to make you little more clear as far as to go for the exercise problems. So let's see the next thing also. Here we could observe this is a sixth point, that is alpha, beta, gamma are the zeros of the cubic polynomial. So we were just taking cubic polynomial, whatever the polynomial which we have taken before, that was a square which is having the only power as 2, but here the power is 3, okay. So if that is power is 3, then the values which we were getting, that is nothing but the roots, are the zeros of the polynomial, that will be getting 3 values. If that is 3 values, definitely that 3 values, one value will take it alpha, next value will take it as beta, and the third value will take it as gamma. So for them we have three things we have to find out here. So these are the 3 things which we have to find out, and that will give the zeros of the polynomial for the given expression. Okay, so let's go forward and we'll go for the exercise and we'll try to do certain problems. Let's go forward. So here we can see this is exercise 3. In exercise 3 there are about how many questions? There are about 4 questions we can observe. So we are going to solve all these 4 questions very clearly in this particular video. Each and every question will be solved very clearly. Okay, so let's go forward and we'll solve the first question. Okay, so you can see the first question. The question says, find the zeros of the following quadratic polynomial and verify the relation between the zeros and the coefficients. So this is the question. In that very first question we can say that is x square minus 2x minus 8. They are giving certain quadratic polynomials. So there are about 6 polynomials were there. For the given polynomial they are asking us to find out the zeros and the coefficients. Okay, that we have to find out. So let's go forward. So I'll just write the given thing, that is x square minus 2x minus 8 is the given. So this part I can write, let x square minus 2x minus 8, I'm just taking it as equal to 0. First I'll just find out the roots for this particular polynomial. So the coefficient here is 1 and the constant is 8, so I can write 1 into 8, that is 8. So I can write 4 2s are 8. So in order to satisfy the middle term I can write here minus 4 plus 2, that will be giving us minus 2. Okay, minus 2 in the sense it is satisfying the middle term. So in the same scenario we'll write here x square, and this is I can just write plus 2x minus 4x minus 8 equal to 0. So here I'll just take x common, so x plus 2 will be remain. Here I'll take minus 4 common, x plus 2 will be remain. From here and here I can take x plus 2 common, so x plus 2 is coming common, so x minus 4 is remained, this x and minus 4 is remained. So then we can write equal to 0. So I'll write separately x plus 2 equal to 0, x minus 4 equal to 0. So if I bring this other twice, so this is x equal to minus 2, x equal to 4. So these are the 2 quadrants, or we can say 2 polynomials which is having the zeros. For the polynomial whatever the given, we got the 2 zeros, that is x equal to minus 2 and x equal to 4. So we can write here, therefore the zeros of the polynomial, what is a polynomial, that is x square minus 2x minus 8, or what are we got, so minus 2 and 4 are the zeros of the polynomial which we got. Now we have to find out the sum of the polynomial and also product of the polynomial, so that we'll do it now. Okay, so let's go forward. I can write what is the general equation for the polynomial, as it is quadratic, so I can write here polynomial is in the form of, so which is the form here for this, it is a quadratic polynomial, right, because the power is 2. So I can write it is in the form of ax square plus bx plus c. Okay, so now we will go for the sum of zeros. I'll write sum of zeros, so that is equal to, what are the values we got, minus 2 and 4 we got. So I can write here minus 2 plus 4 are the values which we got for the sum of the values. So minus 2 plus 4, in the sense we got 2 as the value. 2 I can actually write as 2 by 1, right? If there is no value in the denominator place, we can write just denominator as 1, so I just wrote it as 2 by 1. So this is sum of the zeros in coefficient ways. If we have to write in the form of coefficient, the same thing we can write here. Okay, so what are the values which we got, we have to write like this, right? I'll write down. So coefficients of x, in the sense we should write like this, minus of coefficient of ex by coefficient of x square. So that we have already seen while just observing the introduction of this particular content, that is coefficient of x in the numerator, coefficient of x square in the denominator. That is nothing but coefficient of x in the sense this is the one, right? Coefficient of x, that is nothing but b, but the minus is there as a sign, so I can write minus z. So what is the x square? The coefficient is a, so I can write minus b by a. So whatever the zeros of the polynomial which we got, that also if you just observe here, so minus b, so at that I can write here minus b in the sense what is the value of the b value which we got, that is if you just observe ax square plus bx plus c, and this one here a is how much? It is 1, b is how much? Minus 2, and c is how much? It is minus 8. So we'll write in the same way. So minus b in the sense we got it as minus 2, and a is how much? It is just 1. So we can simply write this as whatever the value we got here, minus b by a, we are getting it as 2 by 1. Okay, so this is the value which we are getting for the sum of the zeros. Either if we do this also in this particular sum of zeros, direct addition of the whatever the value we got it as 2 by 1. Even if you are going with respect to the given equation, that is quotient of x and quotient of x square, for that also we are getting 2 by 1. That is the way, that is the both of the values we should get the same. Okay, so now we will do the product of zeros also. So I can write here product of zeros. Okay, what are product of zeros? That is minus 2 into 4. Same, whatever the values we got, minus 2 and 4, we will just have to multiply them. Sum means we have to add the both values which we got, and product in the sense we just multiply both of the values which we got. So minus 2 into 4 will be getting, that is 2 4s are 8, so we'll be getting it as minus 8. Okay, if that is minus 8, we can simply write it as minus 8 by 1. Okay, both of them were same. So if we write in the form of coefficient for the product, the coefficient we have to write like this. I'll write here constant term, okay, by coefficient of x square. So this is for product of the quadratic equation. So now here constant term in the numerator and coefficient of x square in the denominator. So for the given equation, what is the equation? We'll just write the equation one more time here. X square minus 2x minus 8 is the equation. If we compare with the general equation x square plus bx plus c, we could observe a is 1, b is how much? Minus 2, and c is minus 8, right? So we'll just use all these three values, and we'll just apply over here. Constant term in the sense, what is that we will be taking? Constant is c, right? And what is the quotient of x square? X square quotient is nothing but a, so we can write this as c by a. So what is c by a here? C is how much? It is minus 8, and a is how much? It is 1. So minus 8 by 1 is the value which we are getting. Even when we just multiply directly the zeros, whatever we got, that we got as minus 8 by 1. Here also we got minus 8 by 1. So this is the way we'll be just writing what are the values which we got. So this is the way we will just solve the product of zeros and sum of the zeros if an equation is given. Okay, so this is all about this particular question. Let's go for the next question. So let's go for the second question. So the question says 4s square minus 4s plus 1. So this is a quadratic equation. So almost all the questions were very similar to one to other. So this also we'll just solve as we did for the first problem. So let's go forward. Second, right, let 4s square minus 4s plus 1 equal to 0. So the quotient here is 4, and here the value is 1. So I can write 4 ones, it is 4. So for the roots, I can write here 2 2s is 4. That is exactly satisfying the middle term. So I can write 4s square minus 2s plus 1 equal to 0. Minus 2s in the sense that is minus 4s. So I can take 2s common. So if I take 2s common, will be remain with 2s again. So here 2s, if that is coming common, only 1 will be remain. So here I will take minus 1 common, so 2s minus 1 will be remain. So overall I'll just take 2s minus 1 common, so I'll be remained with again 2s minus 1. Okay, so that is equal to 0. So this I'll write separately, 2s minus 1 equal to 0, this also 2s minus 1 equal to 0. So this I can write 2s equal to 1, s equal to 1 by 2. So this also 2s equal to 1, s equal to 1 by 2. So we got the s values here. So we can write therefore the zeros of the polynomial. Okay, so what is a given polynomial? Right here, 4s square minus 4s plus 1, right? So what are the zeros we got? That is 1 by 2 and 1 by 2. Two of the polynomials we got as zeros are 1 by 2 and 1 by 2 for the polynomial. So as the given equation is a quadratic equation, what will be the general equation for this? So I can write here polynomial is in the form ax square plus bx plus c. Okay, the given equation is 4s square minus 4s plus 1. Okay, and the general equation is ax square plus bx plus c. If we just compare all of them, we'll just means the general equation as I'm writing in the form of x, it doesn't mean that as this is s square, how we could compare x, in the sense we can write even the general equation in the form of s also, it doesn't matter, both are same. I can write a square or bs plus c, so both are same. So however the a values I'm getting here, a equal to 4, b equal to minus 4, and c we are getting is 1. Okay, so these are the ABC values which we are getting from the given equation. So let's go forward. So let's do the sum of the zeros of polynomial. So I can write here sum of its zeros. So that is, we got two values, that is 1 by 2 and 1 by 2. Sum in the sense we just have to add both of the values which we got. Okay, as the denominator is 2 and 2 in both of the cases, we have to just add the numerators. So 1 plus 1 by 2. So I can write 1 plus 1 is 2. So 2 by 2 will be getting the value as 1, where 2 ones are 2 and 2 ones are 2. We are getting sum of the zeros as one of the value. So we'll just further do it. So I can write here as the coefficient of x. That is one thing where they should also have minus. So minus of coefficient of x by coefficient of x square. Okay, where that should be equal to coefficient of x, in the sense we can simply write that is minus b, and coefficient of x square in the sense that is a. Okay, coefficient of x is b and coefficient of x square is a from the general equation that we were writing. So however, whatever the coefficient of x, that value we have wrote above here, you will see here coefficient of x in the sense we wrote is minus 4, and coefficient of x square it is 4. We'll just submit the both of this over here. So I can write minus b, that is nothing but how much, minus b in the sense that is we have just minus of minus 4, and a in the sense it is 4. So I can write here minus of minus plus, so that is 4 by 4, which is 4 can be cancelled, will be getting the value as 1. So here when we directly add the value, sum of zeros we got 1, here also we got the sum of zeros as 1. So now we'll go for product of zeros. Okay, so I can write here product of zeros. So whatever the product of zeros we got, it is 1 by 2, and we'll multiply again, so that is 1 by 2. So these are the two values which we got, so we just multiplied. So 1 by 2 into 1 by 2 is, it is how much? It is 1 by 4 is the value. Okay, so now we'll even do with the coefficients, that I can write here constant term by, that is coefficient of x square. Okay, so what is constant term in the sense that is x, and quotient of x in the sense x square in the sense that is a. Okay, so as our equation, what is our given equation? The equation is 4s square minus 4s plus 1 is the given equation, whereas the constant is c, that is nothing but 1, and the coefficient of x square, that is nothing but 4. So we'll just submit here 1 by 4 is the value. So here when we just multiply directly product of zeros, here also we got 1 by 4, here also we got the value as 1 by 4. So this is all about this particular question. Okay, so we'll go for the next question. So the question here is that the third one, 6x square minus 3 minus 7x. So this is a given question. First we'll just make the question in order, then we'll solve it. So I can write here 6x square minus 7x minus 3. Okay, so this I can write let 6x square minus 7x minus 3 equal to 0. So just above I just brought this minus 7x first and then I wrote minus 3. It doesn't matter, either we can write a plus b or b plus a, both are the same. So here I can write this particular equation. The quotient of x square is a and the quotient the constant is minus 3. I can write 6 into 3, that is 18. So 18 in the sense I can simply write 9 to the 18. Okay, it is just satisfying the middle term because 9 minus 2 it will be giving us 7. So I can write here 6x square minus 9x, this is plus 2x minus 3 equal to 0. So this is the equation. So I can write here this here 9 is a multiple of 3, 6 is also a multiple of 3. So I can write 3x common. So 3 2s are 6, this is 3 2s are. So 3 2s are will be getting 6. So one more x is remain. So 3 3s are 9. So I'll just write 3 here. So that is all about this ones. Here also I can just take only one common. So 2x minus 3 will be remain. From overall I can take 2x minus 3 common and will be remain with 3x plus 1. Okay, so this I'll take separately. 2x minus 3 equal to 0, this 3x plus 1 equal to 0. So this I can write 2x equal to 3, so x equal to 3 by 2. So here 3x, when I send 1 to other side, this is becoming minus 1. So x equal to minus 1 by 3. So these are the x values, that is nothing but the zeros of the polynomial for the given polynomial. The values we got is 3 by 2 and minus 1 by 3. So let's write further. As these are the values which we got, we'll write the conclusion also. Therefore the zeros of the polynomial, that we can write it as, what is a polynomial? 6x square minus 7x minus 3 is the polynomial, and the values which we got are 3 by 2 and minus 1 by 3. So these are the values which we got. So as this is also a quadratic equation, so what is a polynomial? It will become, I can write here, polynomial is in the form ax square plus bx plus c. Okay, so that is the quadratic equation. So that was the form. So quadratic in the sense, what is the equation? 6x square minus 7x minus 3 is the equation. I'll write over here 6x square minus 7x minus 3 is the equation given. If you just compare with the quadratic, that is ax square plus bx plus c. So what is the a value here? A is 6, b is minus 7 and c we are getting as minus 3. So same values, we'll just take it over here also. So first we'll just do sum of the zeros by direct addition of the values which we got, that is the roots. So I can write here sum of zeros. I can write 3 by 2 plus of minus 1 by 3, because sum of the zeros I just added both of the values. Now I can write 3 by 2 minus 1 by 3. So as 2 and 3 different denominators were there, we'll just have to do LCM here. So I can write 3 into 3 minus 1 into 2 whole by 2 into 3. Okay, so this I can further do. 3 3s are 9 minus 2 1s are 2, so 2 3s are 6. So we'll just further solve this. 9 minus 2, that is 7 by 6. So this is the sum of the zeros when we directly add the zeros which we got. So we'll just go with the equation. So I can write here coefficient of minus coefficient. So we have further, actually we have solved much of the problems, so we were just doing this also as the same. So the coefficient of x by coefficient of x square, right? Quotient of x in the sense that is minus b by a. Okay, so what is minus b in the sense, if the given equation, if you write here, that is 6x square minus 7x minus 3. So here a is 6, b is minus 7, c is minus 3. So here b is how much? Minus 7. So I can write minus half minus 7, a is 6. So minus half minus in the sense that we are getting as 7 by 6. See here sum of the zeros, when we directly add we got 7 by 6. This way also we got 7 by 6. So let's go for product of zeros. Product of zeros I write here, product of zeros. Okay, so two zeros which we got is 3 by 2 into minus 1 by 3. So let's multiply the numerators. So this is 3 ones are 3, which is minus 3 by 2 3s are 6. This is minus 3 by 6 is the product of zeros which we are getting. So we'll go with respect to equation also. So I can write here constant term by coefficient of x square. Okay, so what is the constant term in the sense, it is c, quotient of x square is, it is a. Okay, so what is the value of c and a? We have just wrote here, c is minus 3 and a is 6. So we'll just submit over here. So I can write c is minus 3 and a is 6. So these both also we got exactly same. Okay, so this is all about this question. Let's go for the next one. So I'm writing the next one, the fourth one. The question is 4u square plus 8u. So this is the next question. So let's rewrite this as, let 4u square plus 8u, that I'll write equal to 0. So now this particular equation, here 4 multiple is there, here also 4 multiply is there. So I can take 4u common. If I take 4u common, in this I'll be just remain with u, whereas here u is coming out, so here multiple of 2, so that is 4 2s are 8, so 2 is the remained value. So if I just write this separately, 4u equal to 0 separately, u plus 2 equal to 0 separately, so u is becoming 0 by 4, so that is u is becoming 0, and this I can write u equal to minus 2. So these are the two values which we got, u equal to 0 and u equal to minus 2 are the values we got. So we'll write the conclusion, therefore the zeros of the polynomial. So what is a polynomial? 4u square plus 8u. So the values we got are 0 and minus 2. Okay, so the polynomial, what we could take as, this is a quadratic equation which is given, because the power is 2, right? So definitely the given equation is a quadratic equation. So we'll write here polynomial is in the form of ax square plus bx plus c. Okay, so now we'll do the sum of the zeros of the polynomial. So I can write here sum of zeros, that is nothing but, what are the sum of zeros? The zeros we got, u equal to 0 and u equal to minus 2. I can write 0 plus of minus 2, which is nothing but minus 2 is a sum of zeros. So we'll write with the coefficients also. So I can write here minus of coefficient of x by the coefficient of x square. Okay, so coefficient of x in the sense I can write minus b, and coefficient of x square is, it is a. So we'll just submit the values as per the given equation. Here a, that is a is 4 and b in the sense that is 8. So we'll just submit over here, so that I will be getting this as minus 8 by 4 is the value. If you just cancel this 4 ones and 4 twos, so we'll be getting minus 2. See here, sum of the zeros minus 2, here with the coefficients we got minus 2. So let's write the product of zeros also. So I can write here product of zeros. So just we have to multiply the values which we got 0 and minus 2. So I can write 0 into minus 2, which is 0 is the value which we got. So we'll write with respect to coefficients also. So I can write here constant term by coefficient of x square. Okay, constant term, there is no constant term in the equation given. So if there is no value, we can write it as 0, and coefficient of x square, it is nothing but 4. So 0 by 4 in the sense the value will be getting as 0. So here also it is 0, here also it is 0. Okay, so this is the values which we got for the sum of the zeros and product of zeros. So let's see the next question, that is t square minus 15 is the question. This is also a quadratic equation because the power is 2. So let's do this. You can write let t square minus 15 equal to 0. So this is the question where we made it equal to 0. So in this particular one, if we send this 15 to other side, so this is becoming t equal to 15. Square is also there. If we send square also to other side, so this is becoming t equal to plus or minus under root 15. So this, if we just take separately, t equal to root 15, or I can write t is equal to minus root 15. So these are the two zeros of the polynomial we got. So you can write therefore the zeros of the polynomial. So what are the values we got? So the polynomial is t square minus 15, or root 15 is one of the value, and the second value is minus root 15. So as the given equation is a polynomial which is having the power as 2, so we'll write here the polynomial, okay, is in the form ax square plus bx plus c. Okay, so now we'll find the sum of the zeros and also product of zeros. So we'll go for sum of the zeros first and write sum of zeros. So what are the zeros we got? Root 15 and root minus 15. So I can write root 15 plus of minus root 15. Okay, so this I can write root 15 minus root 15. So this is becoming 0 as the sum of zeros. So we'll go for the coefficients also. So I can write here coefficient minus of coefficient of coefficient of x by, this is how much, quotient of x square. So that is equal to quotient of x is how much here, the equation is t square minus 15. There is no coefficient of x here because there is no, so t square is there but t is not there in the equation, so the coefficient is 0. I'll just write over here, that is t square minus 15 is the equation. If we compare the general equation ax square plus bx plus c, here second x term, that is second t term is not there. So here only the first term is there, that is a equal to 1, b equal to 0 and c equal to minus 15. Okay, so these are the values where we'll just take over here. So quotient of x in the sense there is no value, so 0 by quotient of x square is 1. So 0 by 1 in the sense it is 0. So here also sum of 0 0, here also it is 0. So let's do product of zeros also. So I can write here product of zeros. So what are the zeros? Product of zeros, that is nothing but one value we got root 15 and second value we got minus root 15. So 15 root 15 into root 15 is nothing but it was just 15, where the sign is negative, so we can write this as minus root 15 is the value we got for product of zeros. So even we will just take with the coefficients also. So I can write here constant term by coefficient of x square. So this I can write constant term in the sense, in this particular equation what is a constant term? It was minus 15, and quotient of x square in the sense there is the value as 1. So minus 15 by 1 in the sense we can simply write it as minus 15. So product of zeros, here also we got minus 15, here also we got minus 15. So this is all about this particular question. So let's see the next question also. Okay. So the next question is 3x square minus x minus 4. So this is also a quadratic equation. So we can write let 3x square minus x minus 4 equal to 0. So this particular equation, the quotient is 3 for the x square and the constant is 4. So I can write 3 4s are, it is 12. 12 in the sense I can write 4 3s are 12, where it is satisfying the middle term. This is only 1 as the middle term. So I can write here minus 4 plus 3 in the sense we will be getting the value as 1. So I can write here 3x square, and this is I am just writing it as plus 3x minus 4x minus 4 equal to 0 as the equation. Plus 3x minus 4x in the sense again it will be getting as minus x. So here I'll just take 3x common, so I'll be remain with x plus 1. Here I'll take minus 4 common, I'll be remain with x plus 1. So here if I take x plus 1 common, I'll be remain with 3x minus 4. So this I can write x plus 1 equal to 0, 3x minus 4 equal to 0, x equal to minus 1. This is 3x equal to 4, where x will be getting as 4 by 3. So these are the x values, we got the zeros of the polynomial. So we will write the conclusion. So I can write therefore the zeros of the polynomial, what is the polynomial? It is 3x square minus x minus 4 is the polynomial. So the roots which we got are minus 1 and 4 by 3. So these are the two values which we got. So what it is a quadratic equation, so we can write it as polynomial is in the form ax square plus bx plus c. Okay, so this is in the form of quadratic equation. So we'll find out the sum of the roots and also product of the roots. So I can write here, as this is a quadratic equation, we'll just compare 3x square minus x minus 4 is a given equation, ax square plus bx plus c is a quadratic. So a will be getting 3 and b we got minus 1, whereas c we got minus 4. Okay, so these are the values. We'll just take in the sum of zeros. So I can write here sum of zeros. So what are the zeros? That is minus 1 by 4 and plus 4 by 3. So I can write minus 1 plus 4 by 3. So we'll do LCM, minus 1 into 3 plus 4 whole by 3. So this I can write it as minus 3 plus 4 by 3. This is 1 by 4. So these are the sum of the zeros when we directly add the two zeros which we got. Okay, so we'll go with the coefficients also. So I can write minus of coefficient of x by coefficient of x square. Okay, so now quotient of x in the sense, what is the value? That is quotient of x is minus b, quotient of x square in the sense a. So that is nothing but what is the quotient? Now minus b we have just wrote it here, b is the minus 1, quotient of x, and quotient of x square is 3. So we'll write the same here. Okay, minus of minus 1 and this is 4. Minus of minus 1 in the sense that we'll be getting as 1 by 4. So this here we got 1 by 4, here also we got it as 1 by 4. This also will write over here, minus of minus 1 by 4, and this is 1 by 4. Okay, so let's go for product of zeros also. I'll write from here. So product of zeros. Product of zeros in the sense we just have to multiply the zeros which we got, that is minus 1 and 4 by 3 is the zeros which we got. Let's multiply 1 into 4 is minus 4 by 3. This is the product of zeros which we got. We'll go with the coefficients also. So I can write here constant term by coefficient of x square. Okay, what is the constant term in the sense that is minus 4, so minus 4 by, and x square it is 3. See perfectly we got it is minus 4 by 3, here also we got minus 4 by 3. So this is all about this particular question. So we have done with question number 1. Let's go for question number 2.
So let's go for the second question. So the question says, find the quadratic polynomial in each case with the given numbers as the sum and product of its zeros respectively. So the question is saying they have given the product of the numbers and also sum of the numbers. So the first number which is given, that is sum of the zeros of polynomial, and this second number which is given, that is product of the polynomial. So that was given in each case. They have given two values. So they are saying that the given values, the first value is the sum of the 0 and the second value is the product of 0. So by using these two values we should find out the polynomial, the quadratic polynomial. Okay, so that was the question. In previous question, if we just observe, in that question they have given the polynomial. By using the polynomial which they have given, we found the zeros of the polynomial. But in this particular case they have given the zeros of polynomial and we have to find out the equation, the quadratic polynomial. So let's go forward. So very first one, they have given 1 by 4 and minus 1. So I can write here sum of the zeros. Nothing but can write alpha plus beta, sum of the zeros, right? Alpha plus beta, they have given it as 1 by 4. So I'm writing that. And I can write product of zeros also. So I can write product of the zeros. So product in the sense we have to just multiply. So they have given it as minus 1. So quadratic equation in the sense, what is the general equation of the quadratic equation? That we'll write here. That is, let the quadratic polynomial, that we can write it as ax square plus bx plus c. Okay, according to this particular one, we'll just make it out that whenever the sum of the zeros and product of zeros, we'll be using this particular one. I'll write here, that is k of x square minus of sum, that is alpha plus beta, x plus alpha beta, where this k is there, no, here k, that I can write it as k is a constant. Okay, but k is not equal to 0, so I'll write here that also, and k not equal to 0. So then what we have to do here, we'll just further solve this. So k into, so x square will write as it is, this particular one, where the sum of the zeros, that is alpha plus beta, it is 1 by 4, right? So we can simply write minus 1 by 4. Of course x is as it is, x will write, and product alpha beta is, it is minus 1, so I can write minus 1. Okay, so we'll just try to solve this further. So I can write here the k value whatever we are taking, because the value here is 1 by 4 as a coefficient, as the denominator, we could take here the quadratic, means it is any value which we can just assume, so the value will become simple, that is the equation will become more simple, so that we could solve it. So I'm taking this as, if k is equal to 4, then the equation I can write quadratic polynomial will be, so what it will become if I take k equal to 4, so that is 4 into x square minus 1 by 4x minus 1. This is the equation, right? So as I'm taking 4 as the value of k, if I just take 4 inside, so I can take 4x square minus 4x by 4 minus 4 is the expression we got. We can cancel this 4 and 4, and we are remain with 4x square minus x minus 4. So the k value whatever we are taking, it is our wish the value which we are taking, but we should take the k value in such a way that the equation will be more simple. Okay, if that is making more simple simplified equation, that is the perfect value, the k value which we are taking. So now this is the equation which we got whatever they asked, so I can write here, therefore the quadratic polynomial is 4x square minus x minus 4. So this is a quadratic polynomial which is formed by given to sum of the 0 and also product of 0. So let's see the next question. So the next question is root 2 and 1 by 3. So right here, sum of the zeros. So that is alpha plus beta is a sum. So first value will be sum, so I can write root 2. So next is product of the zeros. That is nothing in but alpha into b, where the product they have given 1 by 3, so I can write 1 by 3. So what is the general equation for quadratic? I can write, let the quadratic polynomial that we can write ax square plus bx plus c. Okay, so now what is the equation when sum and product were given? That I can write it as k into x square minus sum, that is alpha plus beta x plus, and the product, right, alpha beta. Okay, so this is the expression. Even we have taken the same thing even in the previous question also, you could observe here. Okay, same, the k is a constant, so I'm not writing in the next question where you might have already understood. So here the k is already here, where k is constant. Okay, so I can just take here, I'm just taking k as 3, so I can write if k is equal to 3, so the quadratic equation or the quadratic polynomial will be, so why I've taken k as 3 in the sense, because the product is 1 by 3, as the denominator 3 will be getting, the k value I'm taking 3, I just submitted directly, you will understand here, so I can write here k x square, the sum is what, it is root 2, so root 2 x plus the product is 1 by 3. Okay, so the k value I've just taken it as 3, so here in the next step I'm submitting 3, so 3x square minus root 2x plus 1 by 3. So if I just take 3 inside, so I'll be getting 3x square minus root 2 3, or I can write 3 root 2x plus 3 by 3. So here 3 can be cancelled, so remaining equation I can simply write it as 3x square minus 3 root 2x plus 1. So this is the equation which we got by using the two values, that is sum of the zeros and product of zeros, which they have given. So we can read, therefore the quadratic polynomial is, what is a polynomial? 3x square minus 3 root 2 plus 1. Of course x is there here, 3 root 2x plus 1. So this is the polynomial which we got by using the two of the values, the product and sum are the two values which they have given. So let's see the next question also. So the third one, that is 0 and root 5 is the question they gave. So I can write sum of the zeros, that is equal to alpha plus beta. They have given 0, the sum as. Product also I can write product of the zeros. Product ends we have to write alpha beta, which they have given it as root 5. So sum and product we wrote. So the general equation, that is I can write, let the quadratic polynomial, that is ax square plus bx plus c. Okay, so what is the equation when sum and product were given? That is k into x square minus the sum alpha beta x plus alpha beta. So where k is constant, as we already know. So now I just submit the things here. K into x square is what? So x square, and sum is what? Sum is 0. So minus of 0x, and the product is what? It is root 5. Okay. So because there is no denominator in this particular problem, we can simply take k as 1 as the value. So I can write, if k equal to 1, the quadratic polynomial. So that will just submit. So in the above equation, if I write k equal to 1, so the equation will become 1 into x square minus 0 into x is nothing but it was 0 plus root 5. Okay, even if you multiply 1 inside also, there will be no change in the values. So I can simply write this as x square plus root 5. So this is the equation, the quadratic equation which we got. So we'll write the conclusion. Therefore, the quadratic polynomial is x square plus root 5. Okay, so this is all about this particular question. We'll see the next one. Okay, so the next question is 1 and 1. This is the values which they gave. So I can write sum of the zeros, that is alpha plus beta is equal to 1. So product of zeros, that I can write it as alpha beta, that is equal to 1. For sum of the zeros it is 1, product of the zeros it is also 1. That was the given thing. So by using that we'll just find out. So the quadratic equation, that is let the quadratic polynomial, so that is what? Ax square plus bx plus c. So this is the quadratic polynomial. Quadratic because the power is 2. So what is the equation which we have to take when there is sum of the values and product of values? That is k into x square minus alpha plus beta x plus alpha beta, where k is constant. Okay, so let's do this forward. So k equal to, that is k into x square minus sum is 1 alpha plus beta, we can simply write 1 into x plus alpha beta is also it is 1. Okay, so this is obtained 1. As there is no denominators in this particular equation, we can take k value as 1 as we took in the previous question. So I can write here, if k equal to 1, the quadratic polynomial will be So this I can write it as the polynomial in the above case. In the place of k, I'll just submit 1. So 1 into x square minus x1, it is x plus 1. This is the equation. So this is becoming x square minus x plus 1. So this is the equation which we got. So we'll just write the conclusion also. So I can write, therefore the quadratic polynomial is x square minus x plus 1. So this is all about this particular question. We'll see the next one. Okay. So next is the fifth one. That is the values minus 1 by 4 and 1 by 4 are the values given. So we'll write sum of zeros. Sum of the zeros in the sense that is alpha plus beta, that was given minus 1 by 4. So we'll do product of zeros also. So product of the zeros. So that will be getting alpha beta, that is 1 by 4 given for the product. So as this is a quadratic equation form which we have to write, so we'll write that as a general equation and let the quadratic polynomial be ax square plus bx plus c. Okay. So when sum and product were given, when we have to find out the equation, so what is the form? That is k into x square minus alpha plus beta into x plus alpha beta. Okay, where here k is a constant, right, and k is not equal to 0. Okay, so then what we have to do this as, so we'll just submit the sum and product in the above equation. So I can write k into x square minus, what is the sum? They have given it as minus 1 by 4. So I can write minus 1 by 4 x plus product is 1 by 4. Okay, so let's further solve this. K into x square minus into minus plus 1 by 4 x plus 1 by 4. So as a denominator place there is 4 as the value, so we can just cancel that 4 by taking k as 4. So I'll write the same here. If k is equal to 4, then we can write the quadratic polynomial will be, I'm writing here in the above equation in the place of k I just submit 4. So I can write 4 into x square plus x by 4 plus 1 by 4. So when I take 4 inside, let's see what do we get. That is 4x square plus 4 into x by 4 plus 4 by 4. So these 4's get cancelled. The equation we are getting 4x square plus x plus 1. Okay, so this is the equation we got, or the expression we got. We'll write the conclusion. Therefore the quadratic polynomial is 4x square plus x plus 1. So this is the quadratic polynomial which is obtained. So let's see the next question. So the next one, that is the sixth one, the values were 4 and 1. So we'll just do this. I can write sum of the zeros. Sum of the zeros equal to alpha plus beta, which is 4. Okay, and product of zeros, so that is nothing but alpha beta, which is 1. Okay, as it is a quadratic equation, we'll just take the general equation of quadratic. So I can write, let the quadratic polynomial okay, that is nothing but ax square plus bx plus c. This is a quadratic polynomial, so we'll just write accordingly. So I can write this as they have given the sum and product of the zeros, so that we have to take the form as k x square minus sum, that is alpha plus beta x plus the product alpha beta. So where here the k is a constant, okay, and k is not equal to 0, okay. So then we can write this as what is the form, that is k into x square, and what was the product, or what is the sum is 4, so minus 4x plus the product is 1. So we'll just further solve this is the equation where we will just take the k value here, as there is no denominator, so we can just take k as 1 over here. So I can write here, if k is equal to 1, the quadratic polynomial, okay, so that will become what, uh, that is in the above k, I'll just write it 1, so 1 into x square minus 4x plus 1. So even if I multiply 1 to the expression, so there will be no change in the values, so I can write this as x square minus 4x plus 1. Okay, so this is the equation which we got for the given values. So let's write the conclusion. Therefore, the quadratic polynomial is x square minus 4x plus 1. Okay, so this is all about the complete second question, which we have solved the complete second question. So we'll go for the third question. So let's go for the third question. So each question is different. The first question, when we see that the question, they have given the expression, by using the expression we have found the product, the sum and product of the zeros. In the second question which we observed, they have given the sum and product of zeros, by using that we have found the expression. Whereas when it comes to third question, they have given zeros of the polynomial, nothing but they have given the roots for the expression. So by using that particular roots, we have to find out the quadratic polynomial. That was the question. So we'll go forward. The question is, find the quadratic polynomial for the zeros alpha beta given in each case. So here are the zeros of polynomial given in each case. That is, they have given the roots. By using these zeros of polynomial, we have to find out the polynomial. So let's go forward. So the two things they have given here, 2 and minus 1. So I can write, let the quadratic polynomial be, what is a quadratic polynomial? Ax square plus bx plus c, right? Where it is not equal to 0, of course. So I can write, and it's zeros. What are the values they gave? It's zeros b, one is alpha equal to 2, and the second one they have given, that is beta equal to minus 1. These are the two values, alpha is 2 and beta is minus 1. So we'll write here sum of the zeros. So sum of the zeros we already know in the previous question we took, that is alpha plus beta, right? So accordingly alpha is there and beta is there, so we'll just submit here alpha is 2, beta is minus 1. So we are just getting to minus 1, which this is, we are getting it as 1 as a sum of zeros. The same scenario will do the product of zeros also. So I can write here product of zeros, that is alpha beta. Okay, so product of zeros, in the sense the first value is 2 and the second value it is minus 1. So 2 into minus 1, we are getting it as minus 2. So sum of zeros we got alpha plus beta, and product of zeros also we got alpha into beta. So we'll use this both of the values, and we'll use the previous method, that is the second question, whatever the method we use, the same thing we are going to do here. So I can write the quadratic polynomial So what is quadratic polynomial? That is ax square plus bx plus c. Okay. For quadratic polynomial, when sum and product is given, what we'll do the same method which we did in the second question, that is k into x square minus sum, that is alpha plus beta plus the product alpha beta, of course, where k is a constant and also k is not equal to 0. Okay, so then what we can do here, we'll just submit the sum and product of zeros here. So I can write k into x square minus the sum, we got it as 1, of course here x should be there, so plus product we got minus 2, so we'll write minus 2 over here. So we'll just for the solace, so we'll be getting here k into x square minus x minus 2. So this is the equation where there is no denominators in the equation. We can just simply take k as 1. I can write here if k is equal to 1, so the quadratic equation or the polynomial, let the quadratic polynomial, that will become as, I can write in the place of k, I'll just write 1. So I can write 1 and remaining we can write as the same. So even if you submit 1, when we multiply 1 also, there will be no change in the equation. So I can write x square minus x minus 2. Okay, so this is the expression or the polynomial which we got. So I can write here, therefore the polynomial is x square minus x minus 2. Okay, this is the first one. Let's go for the second one. So the second question is root 3 minus root 3. So these are the two zeros of polynomial. By using these two, we have to find out the zeros of we have to find out the quadratic equation. So let's do this. Let the quadratic polynomial. So what is the quadratic polynomial? Ax square plus bx plus c, where of course it is not equal to 0. Okay, and its zeros. What are its zeros? That is alpha equal to root 3 and also beta is how much? That is minus root 3. These are the two things given. So we'll just do here sum of the zeros and product of zeros. So I can write sum of zeros. So that is equal to alpha plus beta. So alpha, that is root 3, and beta, that is minus root 3. So we'll be getting root 3 minus root 3. The sum we got it as 0. Okay, we'll even do the product of zeros. So I can write here product of zeros, that is alpha beta. Okay, so the values are root 3 into minus root 3. Okay, so root 3 into root 3, we can simply write it as 3, where there is sign is negative, so this is minus 3 is a product of zeros. So by using the sum of zeros and product of zeros, we'll just submit in the when sum and product are given, we have to form, we'll just submit these particular values in that and we'll be getting the value. So I can write here the quadratic polynomial ax square plus bx plus c is, so we'll write the form k into x square minus sum, that is alpha plus beta plus alpha beta, where k is a constant and k is not equal to 0.
So now we'll submit the sum of the zeros and product of zeros in the above equation. So for that I can write here k of x square minus, what is the sum? It is 0. So 0 of x plus, what is the product? That is, we got minus 3, so minus 3. So now the k value we can just take 1 because there is no denominators in the expression. So I can write here, if k is equal to 1, the quadratic polynomial, so what it will become, that will be, so I'm just taking 1 in the place of above equation, so I can write 1 into x square minus 0 of x is nothing but this will become 0, so plus of minus is minus, so I can write minus 3. So even if I submit multiply this minus with this expression, there will be no change in the expression, so I can simply write this as x square minus 3. Okay, so this is the expression which is obtained. So I'll write the conclusion, therefore the polynomial is x square minus 3. So this is the polynomial which is obtained. So let's go for the next question. So that was nothing but the third one. So we'll write the third one. The question is 1 by 4 and minus 1. So this is the question. So now these are the zeros of polynomial. So by using this 1 by 4 and minus 1, we have to find out the quadratic equation. So let's see that. Let the quadratic polynomial, so that will take it as ax square plus bx plus c, that is not equal to 0. So even will and its zeros also will write, so I can write, and its zeros be, what are zeros? One is 1 by 4 and the second one is minus 1. Okay, so we'll write sum of the zeros, sum of zeros, that is nothing but alpha plus beta. What are sum? Alpha, it is 1 by 4 and beta, it is minus 1. So we'll be getting 1 by 4 minus 1. Once we do LCM, what do we get here? 1 by 4, so 4 comes here, so minus 4, so I can write 1 minus 4 whole by 4, so this is minus 3 by 4. This is the sum of zeros. We'll even get the product of zeros also, so I can write product of zeros, that is alpha beta. Okay, so product of zeros in the sense we'll just multiply this 1 by 4 into minus 1. Once we multiply, this is becoming minus 1 by 4. So sum of zeros we got minus 3 by 4, product of zeros we got minus 1 by 4. So let's take this in the quadratic form, where when sum and product were given, so the form will write here, the quadratic polynomial. So what is polynomial for quadratic? That is ax square plus bx plus c. Okay, so what is the form for sum and product when it was quadratic equation? That is k into x square minus the sum is alpha beta, alpha plus beta x, and the product is alpha beta. Okay, what about k value? I can write k is a constant term. Okay, and k is not equal to 0. So then what we can write here? So the above equation, in the above equation we'll just submit the sum and the product. So the sum we got minus 3 by 4, that will submit here. Okay, so the product we got it as minus 1 by 4, so that I can write minus 1 by 4. So let's further solve this. So we'll be getting this as k into x square minus of minus plus 3 by 4x, and this is minus 1 by 4. So here in the denominator there is 4 as a value. We can simply take the k value as 4. So I'll just submit here if k is equal to 4. So the quadratic polynomial that will be getting as so I'll just submit 4 in the place of k. So I can write 4 into x square plus 3 by 4x minus 1 by 4. So once I take 4 inside, so this expression will become 4x square plus 3 into 4 by 4x minus 4 by 4. So here 4 and 4 can be cancelled, this also 4 and 4 can be cancelled. So this is becoming 4x square plus 3x and this is minus 1, where 4 and 4 getting cancelled. So we'll write the conclusion, therefore the quadratic polynomial so what is a polynomial? That is 4x square plus 3x minus 1. So this is the polynomial, the quadratic polynomial we got from the given two zeros of polynomial. So let's see the next one also. So the next one, that is the fourth one, 1 by 2 and 3 by 2. These are the two zeros of polynomial given. So we'll write here, let the quadratic polynomial so that we can write it as ax square plus bx plus c that is not equal to 0, and its zeros also will write, that is alpha 1 by 2 and beta that is 3 by 2. So alpha is 1 by 2 and beta as 3 by 2 as the two values which they have given. So we can write sum of the zeros. So sum of zeros that is equal to alpha plus beta. So alpha is 1 and beta is 3 by 2 as above. As the denominators were same, you can simply add the numerators. So that I can write 1 plus 3 by 2. So 1 plus 3 is how much? It is 4 by 2. So 2 ones and 2 twos. So 2 is a value for the sum of zeros. So I can write product of zeros also. Okay, product of zeros in the sense alpha into beta. So alpha it is 1 by 2 and beta it is 3 by 2. If you multiply this, 1 into 3 is 3, 2 into 2 it is 4. So this is the product of zeros. So we got sum of zeros and we got product of zeros. That we have to submit in the form where for the quadratic equation when product and sum are given. So the form that we'll write and we'll submit. We can write here the quadratic polynomial ax square plus bx plus c is, so what was the form? That is k into x square minus the sum, that is alpha beta x plus alpha beta. So what is about k? So k is a constant, right, and k it is also not equal to 0. So then what we can write this, so the above in the above equation we'll just submit the sum and product of the values. So I can write here k into x square minus sum is how much? It is 2, so we can write minus of 2x. The product is 3 by 4, that also we'll just submit over here. So this is 3 by 4. You can observe there is 4 as the denominator in the expression. So I just take the k value as 4 so that we can just cancel that 4. Then we'll get the simple expression or the polynomial. So I can write here, if k is equal to 4, the quadratic polynomial, so that will be what? In the place of k, I'm just submitting 4. So this is 4 into x square minus 2x plus 3 by 4. Okay, so let's submit 4 inside. So this is becoming 4x square minus 4 2s are, that is 8x plus this is 4 into 3 by 4. So here 4 can be cancelled, this 4 and this 4 can be cancelled, so we'll be getting this as 4x square minus 8x plus 3 is the value which we got. So this is the polynomial which we got, so we'll write the conclusion. Therefore the quadratic polynomial is 4x square minus 8x plus 3. So this is the quadratic polynomial which we got by using the two of the zeros of polynomial which they have given. So this is all about this start question. So we have to go for the fourth question. So let's say the fourth question. The question says verify that 1 minus 1 and plus 3 are zeros of the cubic polynomial x power 3 minus 3x square minus x plus 3 and check the relationship between zeros and the coefficients. So this is the first problem which we are doing for the cubic polynomial. So here they are asking the relationship between the zeros and the coefficients of the values. So let's do this. What is a given polynomial they give? That we'll write given polynomial. So that is x cube minus 3x square minus x plus 3. So we can write let p of x equal to x power 3 minus 3x square minus x plus 3. This is a given polynomial. So these are the given values, that is 1 minus 1 and 3. They said they are the zeros of the polynomial itself. So we will write accordingly. First 0 we were just taking the 1 as a value. So I can write p of 1. So in the place of x I'm just submitting 1. So I can write p of 1 equal to wherever x is there I can just submit 1. So 1 power 3 minus 3 into 1 square minus in the place of x 1 again plus 3. So let's see what do we get. This is 1 power 3 is 1. So this is 3 into 1 square is nothing but 1. So 3 into 1 is 1. So minus 1 plus 3. So this will be getting plus 3 minus 3 can be cancelled. Plus 1 minus 1 can be cancelled. P of 1 we are getting it as 0. So the one value which they gave, that was perfect. That was the 0 of the given polynomial. So let's even find out the next polynomial also. So I'm just writing the next polynomial, that is p of minus 1. Okay, so first I'll just write the expression, that is p of x equal to x power 3 minus 3x square minus x plus 3. Right, this is the expression wherein even will submit the value, that is p of minus 1 we are just taking. So minus 1 whole power 3 minus 3 into minus 1 whole square minus of minus 1 plus 3. So now this I can get it as minus 1 whole power 3, in the sense we'll be getting minus 1, because minus 1 whole power 3 in the sense minus 1 we are multiplying for 3 times. So minus 1 into minus 1 is plus 1, whereas again this plus 1 into minus 1, that will become minus 1. So I can write minus 1 is, so this is minus 3 minus 1 into minus 1 whole square is 1. Okay, so this is minus 3 and this is 1. Minus of minus plus, so plus 1 plus 3. So this I can write minus 1 minus 3 plus 1 plus 3. So minus 1 plus 1 cancel, minus 3 plus 3 cancel. This also we are getting as 0. So p of minus 1 we are getting it as 0. So second 0 which they gave, that was also perfect. So let's go for the third one. So the polynomial is p of x equal to x power 3 minus 3x square minus x plus 3, whereas the x value is plus 3, so that will submit here p of 3 equal to 3 power 3 minus 3 into 3 square minus 3 plus 3. So wherever x is there I'm submitting the value x as 3. So this is becoming 3 cube, that is 3 cube in the sense 3 into 3 into 3. So 3 3s are 9 and 9 3s are, it is 27. Okay, so this is 27 minus 3 into 3 square is 9, that is 3 3 is 9. So this is minus 3 plus 3. So this we can write 27 minus 9 3s are, again it is 27. So minus 3 plus 3. So plus 27 minus 27 cancel, minus 3 plus 3 can be cancelled. So this p of 3 we are getting it as 0. So p of 1 we got 0, p of minus 1 also we got 0, p of 3 also we got 0. So whatever the zeros of polynomial which they gave, that was perfect. So they are the zeros of polynomial. So we'll use that and we'll go forward. So I can write here, therefore 1, what is the next one, minus 1, and the next one is 3. So they are the zeros of the polynomial. So we'll write the polynomial also. What is the polynomial? That is x cube minus 3x square minus x plus 3. Okay, so this is the polynomial. For that polynomial, these are the perfect zeros also. So we'll just do the further things, that is, so alpha equal to what? That is 1. We are just writing for this only, and beta is minus 1, and gamma, that is 3. These are alpha, beta, gamma values, and even we'll compare the general equation with the given equation, and even we'll find out the a, b, c, d values also. So we'll do that. So I can write here, compare the polynomial with ax cube plus bx square plus cx plus d. Okay, so let's see what do we get. So the given polynomial is x cube minus 3x square minus x plus 2. This is a given expression. This one I'll just compare with this one, so I can get ax cube plus bx square plus cx plus d. So once we compare, we are getting here a as 1, b as minus 3, and c as minus 1, and d as the value is here, it is 3, it is not 2, it is 3. So d is equal to 3. Okay, so these are all the values, that is a, b, c, d values, and also alpha, beta, gamma values also were there. So that we'll just submit in the forms. That is for the quadratic equation we have already discussed while we are discussing in the introduction part of this particular video. There also we discussed for the cubic, so that I'm writing here. For some, that is alpha plus beta plus gamma. Okay, this is one of the form which we have to find out over here. So this is alpha, that is alpha plus beta plus gamma. Alpha is how much? That is 1, and beta it is minus 1, and gamma it is 3. So this is becoming 1 minus 1 plus 3. So this we are getting 3 as the value for alpha, beta, gamma sum. So even the next thing we have to do is alpha beta plus beta gamma plus gamma alpha. So this also I'll just submit here. Alpha is 1, beta is minus 1, and again the beta it was minus 1, and the gamma it is 3, and gamma is 3, and alpha is 1. So now this we can further solve. So this is nothing but minus 1, this is minus 3 plus 3. So this plus 3 minus 3 can be cancelled, this we are getting it as minus 1. So we'll do the next one also, that is alpha beta gamma. So that is alpha is how much? It is 1, beta is minus 1, gamma it is 3. So for this we are getting it as 1 into minus 1 is minus 1, minus 1 into 3 is minus 3. Okay, so let's even compare with the coefficients also. So that I'll just do over here for this first one. For alpha plus beta plus gamma, So I'll write here alpha plus beta plus gamma. For this the coefficient is minus b by a. Minus b in the sense that is here in this particular term minus b in the sense that is x square term, whereas a is x cube term. So what is minus b here? It is minus 3, so I can write minus of minus 3 and a is 1. So minus of minus in the sense that is simply I can write 3 by 1. Okay, 3 by 1 in the sense we can simply write it as 3. So here also it is 3, here also this is 3. So that was perfect. We'll see in this particular part also. For that alpha beta, so here there is no space, so I'm just doing over here. So alpha beta plus beta gamma plus gamma alpha, so that is equal to c by a. Okay, so now c by a in the sense we'll just see the values. C is how much? It is minus 1, a is 1, so I can write here minus 1 by 1. Minus 1 by 1 in the sense we can simply write it as minus 1. See here, alpha beta plus beta gamma gamma alpha we got minus 1, so this also we got minus 1, so this is also perfect. So even this part also we'll just check it out, that is alpha beta gamma that is equal to minus d by a. So this will just compare what is d and a values. So d is 3, a is 1, so I'll just submit over here. So d is how much? T is 3 where the sign is negative, so this is minus 3, a is 1, so we were just perfectly getting it as minus 3. So this is also minus 3 and this also we got minus 3. So we got perfectly whatever the values which they gave, either the zeros of polynomial and also the equation or the polynomial which they gave, and that was also a perfect, where we got the sum and the product values. For the cubic equation we got the perfect values. So we have covered all of these 4 questions in this particular exercise very clearly. I hope this is very clear to you. Just keep solving all these questions clearly. That will definitely help you. I hope this is very clear to you. So just keep going, just keep practicing all these problems. Even the exercise 1 equation, exercise 2 also, just go through that and practice well, and this exercise 3 also just go through properly. Hope that will definitely help you. So keep going, stay tuned.